Okay, so let's get started, and maybe some people come in a few minutes. So word on reflection two, it's due tonight. So I sent out an email on Canvas. And so, yeah, get that in. I'm not gonna penalize people for being late, but if you need to, they'll need to turn it in. I have, I think, 4 submissions. So I don't know. If people are on top of that, hopefully. I haven't checked it since this morning, so. Okay, so, and then next Wednesday will be, getting reflection 3. So that's going to be on workflows, flow management. So I'm gonna give you sort of a template. I can't remember exactly what the assignment is, but you're going to have to, and I'll talk about workflows between now and then, but you're going to have to sort of plan out a workflow for your. So whatever project it is that you've been working on through reflection 1 and reflection 2, reflection 3 will have that you'll work on workflows. From reflection 2, you'll have technical debt. From reflection 1, you'll have your project vision. And so that will help you along to, sort of realize your project, I think, at a more detailed level than you otherwise have. And so then the week after that, we're gonna have a session where we're gonna talk about our projects. People can come to class, and with ideas. I'll sort of have like a whiteboard where we'll list our ideas out, and I'll kind of go through what to expect in the final paper. So all that will be the week after next. So we were talking about documentation and discussion groups, and sort of following from community building. And so today I'm going to talk a little bit about documentation as a form of community organization. And we're going to get into some topics related to that. But before I do that, I want to back up, cover 2 sort of maybe diametrically opposed types of project management. So these are different schools of thought in terms of project management. And I'm going to focus on, well, I'm going to talk a little bit about waterfall and then talk about agile methods. And both of those are relevant here because both of these involve documentation. So I'm going to kind of touch on agile methodology as we go, especially through the rest of the course. I'll touch on different things that are agile-like, and I'll bring them into the class. But right now I want to make this direct comparison between waterfall and agile. So back in about 1970, waterfall was developed. It was developed in response to sort of the advent of the computer, and then you had a large influx of programmers into the field of computer science and computer programming, and they didn't know how to do anything in terms of project management. It just kind of like came in, did their coding, and it was very discordant. You had these large projects where you had to build software. So no one knew how to really do that effectively. So you started to get these sort of project management methodologies. We talked earlier in the class about different types of like industrial era project management methodologies, Gantt charts, and people working on sort of characterizing the factory floor and thinking about project management that way. You needed a different type of approach for information science, computer science, because you have different workflows, you have different ways of producing things. And we talked about in the very first class that we have these different modes of production in like programming. We have open source, we have proprietary, and those sorts of things actually kind of sprang out of this era as well. So open source kind of sprang out of the same era. So we needed this whole new set of methodologies. And so with waterfall, we got that. It starts with, what basically waterfall is where you have these project phases. You have concept, design, develop, and test. And so each of these phases are distinct phases in the project. You start with some concept, work on a design, you develop something, then you test it, and then eventually you deploy it and you maintain it. And you can see that like each of these phases are connected through this waterfall. So you do things at the concept phase, that flows to the design phase, that flows to the development phase, that flows to the test phase, and so on. So there are specific requirements for this waterfall methodology involving documentation, which we'll get to in the next slide or in the next couple slides. But I want to contrast that right now with agile methods. So agile methods are very different from them. And they kind of, agile came a bit later. Agile came in the wake of the internet revolution around the year 2000. So this is where open source was starting to ramp up. This is where we had people who needed to develop things very quickly because technology started to change at a very fast pace. So, you know, the internet era, you had things that would be sort of state of the art, and then they would change within 3 years. So it made no sense to devote a lot of time to developing a project like waterfall if you're doing that kind of fast iteration. And so with agile, you have this very tight set of feedback loops. So you have a design phase like you have here. You have a test. You have a development phase where you test, and then you produce an artifact, and you look at that and you evaluate it, and then you figure out what's right and wrong with it. And then you design again, then you test it, and you keep doing this until you get a satisfactory finished product. So you can think about, like when we talked about some of the open source methodologies where we have people in the community who are working on building features and refining the design and all this stuff. This is what they're kind of doing. It's agile. They're doing this design, they're doing testing, they're refining iteratively what they're doing. You can imagine if you even had a neophyte, you didn't know anything really about software. You could ease them into software development much more easily with agile than with waterfall, because you'd have to fit them into a team, and that you wouldn't necessarily know everything that was going on with every team, and it would be very opaque. So that's why I'm kind of like going to sort of compare agile and waterfall in terms of the documentation, because as it turns out, the documentation is an important part of this. So a few more words on agile. Agile designs for ultimate flexibility and speed. And you may have heard the term move fast and break things. This is where this comes from. It's basically where you move very fast through these iterative cycles, and you break things, meaning that you don't have a lot of specs. And that's what we'll talk about in a minute, is that your specifications, you don't have a lot of specifications. You can break the rules as long as you can figure out a way to get around the rules. And sometimes that if you have this methodology intersects with society, sometimes it's literal. But and I think you've seen this with open source, where you have to sort of navigate new license types and everything. But anyways, so basically you can move very fast with an agile system, agile methodology. You don't need a lot of documentation. You can do this design very fast. You basically break down every task into its smallest units. So if you have like some task that you wanted, like big tasks, like I want to create an application for this purpose, like playing games of cards or playing tic-tac-toe. I can do that, but it's a very big, to-do thing, very big issue. I don't know how to tackle that directly. I could say we want to do that, but then I say, how do we? I don't know exactly what the steps are or anything else. So in agile, in waterfall, you have documentation help. And we'll talk about that in a minute, but every stage you have this very thick, voluminous documentation. In agile, you don't have that. You just break every task down into the smallest units, you analyze it, you say, okay, this is what happens with this task. First of all, we have to build like a program for card shuffling, position shuffling or something, and you build these pieces in place and you assign those things to different people. And that's how you work. You work through communication, not so much specs. Now in agile, you can get things done fast if you give frequent updates. And if you have really good communication, and you can change direction on it. So in agile, you could really, kind of change direction in your project. If you're doing one thing and you find out something else, you shift to something else pretty quickly. Or if like The technology dictates you could change to the new platform. And I think from like working with technology that every few years, sometimes you have new platforms, new versions of operating systems, new versions of software that you need to be able to address. And so that's where we are. Well, so if you're familiar with Scrum and stand-ups, if you're familiar with teams and Agile, and Scrum is basically a group of people who are working together, communicating daily, sharing, information through discussion forums and other types of ways to communicate. And then stand-ups are a way to sort of work. We talked about Slack bots the other day. That's where we talked about stand-ups. That's all part of Agile. That sort of luminous communication, keeping the team good together, making sure you're updated as to what people are doing on a daily basis at the basis of the smallest unit. So waterfall started in about 1970. And like I said, waterfall really does focus on documentation. So, waterfall, every phase of the waterfall methodology, you need a lot of documentation. Specifically, you need a lot of specifications. You need to specify what you're doing, how you do it. There are all sorts of ways you can do this. You actually can do these sort of work breakdowns where you go through and you assign things to people. But it's not like an Agile where if I assign you a task, I assign it to you because you're good at something. But if you're busy, I can assign it to someone else. In waterfall, it's very specific to sort of a member of the team or a certain team that gets chosen. So there's a lot of sort of upfront planning and specification here. And that requires a lot of documentation, a lot of writing documentation and, publishing updates to documentation. And as you can imagine, that takes a lot of time. And some teams actually use waterfall effectively, but those are usually teams that they're building something like a nuclear power plant, or they're building an airplane where safety is very important, and they have a lot of regulations to deal with in the first place, so they have to write the specs. Two, they have, it's really it does take up a lot of time. And so one of the things that people found frustrating about waterfall is that it didn't allow them to sort of shorten that time span of what they could do. And it was very hard to change things in waterfall once you wrote the documentation. It was like steering a freighter. Very hard to change direction because there's so much there to change. And so this was why in about 2000, we had started, people wrote the Agile Manifesto. So the Agile Manifesto is at agilemanifesto.org. And they propose a bunch of sort of principles for Agile development. And basically, this is not just through frustration with waterfall, because waterfall still exists, but it was enabled by better technical. So a lot of the things I've been teaching so far in the class, using GitHub, using version control specifically, different types of things like Jira, or other types of ticketing systems and project boards. Those were all things that were either non-existent or done manually back in 1970. And so you couldn't really develop a project management methodology around that if you didn't have the ability to put that into practice. Back in 1970, ticketing systems manual, and they weren't as automatic, and they didn't use automation. So it was a little harder to use them effectively. And they didn't have anything like version control. So Agile was really enabled by a lot of these technical advances. In Agile, of course, we break problems into digestible components, and we don't worry about documentation very much. We just kind of use communication as a stand-in. With lean documentation, which is something that is a part of Agile, and so it's specific to documentation, communication replaces reliance in them. As you'll see, we'll still have documentation, but communication is really filling the void of all the specs. And so if you're interested, there's a link at the bottom of the slide, a brief history of the Agile method, which will give you some information about how the Agile method came to be. So this is the waterfall approach, kind of broken down in these phases, but also stressing all the documents you need for, say, like a large program. You're writing a large program. So, you start with sort of this, so you have these boxes over here, which are these project phases. And you're going from the system requirements, software requirements, to the analysis, program design, coding, testing, and operations. So you're going through each of these phases in order, and each of these phases has a team devoted to it. And then each of these phases actually have documentation associated. So in this case, for this waterfall here, you have 6 documents, at least 6 documents that you need to create. The first one is software. Then you do a software review. Then you end up with preliminary design specs. You do, warm review, analysis. You get documentary interface design, that's a spec. Number 4 is final design spec. Number 5 is test plan spec. Number 6 is operating instructions. So that's a lot of specs. And each of those specs might be, maybe 100 pages long. Depends on the program. If it's an operating system, it might be 100 or more pages long for each one of those. You have to have someone write those up, everything detailed out, spelled out. And of course, in some cases, this is very useful because in some cases you have to deal with regulators. In some cases, you have to deal with, everything has to be at a very high tolerance, no room for error. You can compare that with agile. You're just kind of doing it by the seat of your pants, and you keep testing new things, and you see what happens. So it's really interesting, the contrast. So in waterfall, we really have a lot of documentation, and it requires not only a lot of documentation, but this sort of technical writing skill, where you really have to be efficient with your words because you have to be very specific. So, and then of course, when things change, you can version these documents, but people have to become familiar with the changes and everything else. And it's a huge, like I said, it's like changing direction with a freighter, steering a freighter in a new direction. It's so big that you can't turn it effectively. It takes a while to change things. So in Agile, they actually have these 4 pillars of Agile, and it's very different from Waterfall. So, you have processes and tools that you use in Agile. So we use GitHub, we use Jira, we use, Markdown, we might use some compiler. Those are all processes and tools. But really, the thing that makes Agile work is the individuals and interactions. If I have a team of people, that team has to be, I have to sort of value each one of you. We all have to communicate on a daily basis. We have to make sure that we understand the objectives of the project. We have to sort of take accountability for our own actions. So I might assign each of you some tasks, and I want you to report on it daily, what's your progress, what are your blockers, etc. And then you're ultimately responsible. So that's how you can manage people in Agile without specs, without documentation. The second is that, of course, comprehensive documentation takes a backseat to working software. So the idea isn't to build all this documentation and tell me how to build the software. You just build the software. So I think that like a lot of startups, they just build working software and they just, keep working on prototypes or they keep working on versions. And, that's the important thing, is to get the software working and then refine it from there. And so that's, it's a lot shorter timeline, but then you lose a lot of the specs that you would have had. With respect to contracts and bureaucracy, collaboration is preferred over contracts and bureaucracy. And of course, that's relevant to documentation because you need less of it in open collaboration. You can just talk to someone in a discussion chat, talk to someone in a face-to-face meeting or on a video chat and work something out with them. And then finally, following a plan, which of course is where you have all these specs. In Agile, we care more about responding to change. So this is kind of an idealized thing, but basically, when you have plans, you have sort of a fixed mindset where this is the way things are going to go and nothing will derail us from this. But of course, the world changes quite drastically, and it can change quite drastically. And so having this ability to respond to change quickly is very useful. Now, that doesn't mean that you shouldn't ever try to follow a plan. It just means that in Agile, they value responding to change over phone. And because, we talk about not just specs, but we also talk about roadmaps. And those roadmaps will go for, you can plan out several years in advance what your project might achieve. And you in fact have to do that because you have to offer some vision to where the project is going. The only difference is in Agile, you can change that direction, or you can change sort of the timing of that, the direction much easier. And so, if we think about documentation as sort of an investment in time, which it is, and you can see that you get this sort of benefit. And the benefit is that you don't spend a lot of effort writing docs. So this is this red line is sort of the traditional approach. And this is, basically a waterfall. It could just be, other types of methodologies where people write a lot of specs in advance. And you can see that, when you have these detailed specs of different types, a detailed project plan, you say, I'm going to do everything a certain way, that you spend a lot of time up front writing documentation. In fact, it's one of the most important things you can do early on because you have to stake out sort of the scope of the project and everything. And so, you spend a lot of time for making this documentation. And as you go through the project, you spend maybe a little bit more time maintaining it. And then finally, you get to the end of your timeline here, and you're putting in support, operation, and user docs. It's usually when you have a product ready to go, and there's a bump up in effort there. So you end up spending a lot of time, a lot of effort, putting a lot of effort into making docs. Now with Agile, by contrast, you spend almost no time putting effort in docs. You have a high-level plan, you have requirements, and you have general architecture that you define early. And this actually allows for a lot of rescoping of projects. So if you're working on a project and you find that some of your issues that you've staked out, or your project vision is too ambitious with resources that you have, then you can scale back. And it doesn't hurt you. And you haven't spent any time making docs to say that you're going to do this. So it's very, very lean in that sense. And so you spend very little time on docs here. You kind of ramp up as you go along, you build more docs in, and then you get this bump up at the end where you're putting in a overview document. So with Agile, you spend very little time on documentation, but you have to document things because you have users. If you have an open source community, you have community members who need to know how things. And like I said, you don't want to keep everything, you don't want to have a team where everyone keeps everything in their head. You have to have things out in sort of a public domain, at least for the project, where people can draw on it. So if someone leaves the organization because they're burnt out, but they knew how to do certain things in the organization, called organizational memory. That organizational memory is it's not just lost. And so that's something that you may lose in Agile, so you have to be aware. Because there isn't this culture of making docs, you have to have a specific plan for preserving that institutional memory. So this is just a way to think about depending on the project management paradigm you pick, you're going to be doing things like making documentation, and those have, depending on the way you approach that, those have very long-lasting effects on your resources and what you get in return. So thinking about how Agile Lean approaches documentation, there are a couple of core practices. And these core practices are kind of some of them are kind of almost tongue-in-cheek, it seems, because it's hard to really know what they mean. But this is kind of from this agilemodeling.com site where they kind of list them out, and you can get a sense of how much effort should you put into documentation if you're taking sort of a minimalist view. Documentation. So the first is keep documentation just simple enough, but not too simple. And so that means that you want to have very simple readmes, like we did with our first quiz. You want to have a readme that describes what's in the repository, what is in there, how maybe a piece of code works, maybe some guidelines, there's just enough documentation to tell people. But you don't want to make it too simple, like, look on this lengthy book here. Remember, we talked about technical debt, where if you make things too simple, if they're too sparse with the information you're giving people, it can hurt you, because they can be very confused, very discordant. And remember, in Agile Lean, you need to coordinate groups. That's kind of your goal, so you don't want to work against it. You want to write the fewest documents with the least overlaps, and this is kind of counter to waterfall, because in waterfall, you're making specs for everything, and sometimes they overlap. But usually, it's hard to make sure they don't overlap. 100-page documents for. But in Agile, you have to come up with a strategy to say, we're gonna maybe write documentation for this repository, and this repository, and this directory within a repository. Just stick to whatever's in that area. And so we don't overlap with our documentation. You write relatively few documents. And you have to develop a strategy. Put the information in the most appropriate place. This is where READMEs come from in GitHub, where you have this file that just kind of describes what's in that repository or what's in that directory. And it's very simple. People know kind of to go there, read it. That comes from like in programs, when you get a program that like on a disk or something, they would have like a README that would describe what was in the program. So there's this sort of lineage back to like traditional programming. And then display information publicly. So again, this is where you want to make sure your team members, your community knows that, where to find the documentation and that it's available easily so that they can interact with it. Otherwise, your documentation is that useful. Iterate, which means that like in project design, you want to keep changing your documentation. Very hard to deal with a piece of documentation that's like 2 or 3 versions behind the product. And we talked about technical debt, and this is one of the things, of course, that introduces technical debt. When your documentation is wildly out of sync with what you're doing, you say all this stuff, like you say you had this very large project vision and you had to rescope your project because you came to your senses and said, there's no way I can do it. And so your documentation does not reflect that, reflects your previous project. That's obviously a problem that is technical, that where you then have to invest time updating these things, sort of post hoc, and you have to figure out how to write it, and then they actually take more effort. It's better to make the effort right when things are written, things are fresh. Spend less time. Find better ways to communicate. So maybe it doesn't need to be a doc, maybe it can be a discussion thread in a discussion forum, maybe it can be a conversation on video chat, maybe it can just be like, maybe like something else that we talked about. Maybe you just need to incorporate it into your community standards or something. There's just better ways to communicate than putting things in docs and making people read through all these docs that are maybe even unclear. Start with models you actually keep current. So make sure that when you have a strategy, that model is something that your organization can follow. Don't force people to write in this really complex template or write these 100-page documents that no one's going to read. But moreover, you have to spend a lot of time kind of working through and updating. And sometimes teams will not even have a technical agent. They'll just use their own people, and people will maybe be required to write some documentation, just enough to make sure people know what's in the repository. So there are a lot of strategies for this. And then finally, update only when it hurts. So you do want to update, but you don't want to update like every time you write a couple lines of code, every time you correct it. You want to have like regular updates in your documentation strategy. So you might say, we're gonna spend, every month or two, we're going to spend some time updating documentation. Or we're going to have an event where we update our documentation. If that's where we'll do it. And we can accomplish this in regular intervals. It'll be fresh. It will be, we'll try to make it relevant, and we'll focus the mind in some sort of sort of event rather than writing all these documents in advance or having to spend a lot of time updating things many iterations later. So if you're interested in finding out more about open source documentation and documentation in open source projects, I have a list of readings here. This is just kind of, this is from this agile lean perspective. So when they talk about building great open source documentation or the anatomy of great open source documentation, this is really about like this sort of agile. But these are different specific examples of how people approach this. So if I go back to this, there's this third article, 5 tips for making documentation a priority in open source projects. So these are kind of, how do you make this? How do you make sure that your people in your project or development team or your community are writing documentation? Because, especially if you have people from your community who are contributing, one of the things they'll overlook, of course, is writing out documentation. They make a great contribution, but they write no documentation, and it's kind of useless if they don't do this and then you have someone else do it and they don't understand that. So, it's really something you need to encourage, at least within the project, but ideally within the people who make the contributions. So here's some tips that they give, recommendations, and they won't work for every project. The first is value contributions to documentation just as much as code contributions. So code contribution, you might use a leaderboard. You might say this person's really making some good contributions to the project, and they're getting maybe even paid for it, or they're getting recognition, and there's some gamification system around someone contributing code, and that's great. And then for documentation, you just leave it up to chance, and you say, by the way, write some documentation. I don't care what format it's in, just do it. And of course, people will overlook it because there's no incentive, right? There's no, there's no sort of intrinsic or extrinsic motivation, really. Other than like, well, people can use it later. That's sort of an abstract thing. It doesn't count. So make sure that when you want people to write documentation for code, make sure you have a system in place that will allow them to see their value in what they're doing. And a lot of times that's the same things you do for code. You might have like a leaderboard, you might have these other types of rewards that people get for doing this. Number 2, put documentation and code in the same project. So that seems obvious. Basically, that's why they have READMEs in a project repo. But also, you don't want to have a specific area for documentation, because although, like in waterfall, they have specs and they might put them in a special place. If you're doing something like open source or like with agile, you have people coming in and out of project or in and out of repo and looking for things. It makes it easier to have the documentation. And so that's something that, is just an organizational point, but it's important to have those things organized together. Make documentation a requirement for a merge or release milestone. So this is where we have, like, if you're contributing on GitHub and you issue pull requests, and I see that you don't have any documentation, I don't accept your pull request until you have documentation. And your organization might have like templates for documentation. Here's how you do this. If you want to make a contribution, of course, make the contribution, write the code, but here's a template for making documentation and, making sure that it comes at the same time as the pull request. Or, if you're making a release of some software, so sometimes people will work on software in this dev branch we talked about, and then they'll put it into the prod branch, so they'll put it into production. And so maybe one of the criteria for putting it in production isn't just that it works well, relatively bug-free, but that it also has documentation. And that's something you can, that's a governance issue you can solve with community standards and templates, things like that. Have a consistent contribution process for code and documentation. So work that into your sort of workflow if you're, someone's working on code, or if they're working on like, some project in there and you assign them an issue. You might assign them another issue to say, always remember that you want to have documentation. And, put that into the workflow, so you say, to write code, we write some code, we get it, maybe we do a test. And then we have some code review, and then we do another test, and then we also look for the documentation of that and review the documentation. So you place it right into this work. And like I said, we'll talk about. Then finally, have a well-documented process for contributing. So if people don't know how to do this, you're not going to do it. This is too frustrating. And that's when you want to have these templates where it's like, you can have a template in Markdown like we had for the, I didn't have one for quiz one. You'll have one for your final paper. Where there's like, there's specific stylistic elements that need to be there. You might have like, put together like a template where all they need to do is fill out parts of the thing. You might ask questions, they might answer the questions, and it can be done pretty easily through a template. And just because, people don't know how to structure documentation, they're not a technical writer, so you might just guide them through the process and say, what did you, how do you use this thing? How do you update this thing? How do you install this? And people answer those questions and it fits right into the slots. And it makes it much easier for people to pay attention. Okay, so there are multiple types of documents. So we talk about documentation. In Waterfall, we talk about writing these detailed specs. In Agile Lean, we talk about minimal documentation. But there is, of course, some documentation. And of course, there's documentation along with code. But a lot of times, if you have an open source community, you aren't just writing documentation for code, you're writing documentation for like users or for people who have different levels of skill in terms of understanding how to use your software, whatever you're building. And so a lot of organizations will have they'll take documentation from very technical things to these sort of multi-layer expositions of their project. And so what I mean by that is that you have all these different types of documents, and they're by different types of people, they have different functions. So the reference file, for example, will have the technical details. This is like a traditional spec. And so this will tell you what is in, what's going on in a certain phase of the project or certain one piece of code or, whatever, and it'll tell you a lot of the technical details. But then you also have the README file, which is a showcase of what's in your repository, what files are there, what you do. That's sort of similar to the technical aspect. But then you also have these other ones, like how do I install this project and use its code? This is for someone who isn't that technically savvy but still wants to use the code. And you might ask very what they call stupid questions, and you can answer those not by treating them as stupid questions, but by saying, okay, take them by the hand and say, this is how you typically install this and how you use the code, and walk through it that way. So it's sort of like a tutorial. There's also the why would I use it frequently asked questions. So that might be like, I know how to install it. I basically know how to use the code. It's obvious, but why would I invest my time in this? And that's when you can sell what you're producing in your project and sort of go through some frequently asked questions. What is this useful for? Why do I want to do this? The number of questions you can kind of anticipate in this document. What are its functions and what do they do? It's a very similar thing where you drill down to a finer, very technical level. There are things like cookbook files and guide files, which really are kind of like where you kind of take users by the hand and you give how-to instructions for specific tasks. Like, here's how you would use this program for, doing some accounting, doing your taxes, versus like doing some business accounting, some other type. Just things like that. And you use these use cases as a way to sort of guide people through. So it's not just documentation for the technical aspects, so the technical specs, of which you shouldn't have that much if you're following Agile Lean. But you have these other types of, things for users, for the community, for people to interact with your project. And then finally, you have these kind of blog post type why question documents where, you might say, why is this project significant? Or why is this program constantly changing? Or, you answer questions that are not really technical questions, but they're sort of philosophical. And, that's something that engages people who may not even be in your community. They may be out in the world, in the greater world where you want to reach people, to bring them into your community, or bring them into your contact with your project. The very, eventually you can create a very useful ecosystem for your project by building these kind of documents, not spending huge amounts of time on specs, but diversifying what you have in terms of documentation. So this is an example of sort of a traditional reference manual. This is for the Apple II. This came out in January 1978. Needless to say, this was all in a print book at the time it was released, but it's in this PDF form. So you can see that it has 155 pages. It has everything, you might want to know about this product. It has, unpacking, filling out the warranty registration card, running your first program, telling you something about colors. You have to remember back then, it wasn't just that people didn't know how to use the Apple II. It was a sophisticated machine. People didn't have a mental model for how to use it. So they had to have all this documentation up front. They had to say, here's how you program with BASIC. And a lot of people had no idea what BASIC was or how to use it. So they had to teach them that. Because at the time, to use a computer, you would often have to program things. Because there weren't, programs made that were suitable for what you wanted to do. So you'd have to have, programming stuff in here, different examples, basic programs you can write. There's firmware, there's hardware, kind of going through everything. So it's a pretty comprehensive document. Now I bring this up because kind of shows you an example of it. This was developed sort of under this waterfall methodology, and it follows that kind of logic where you're writing specs for everything. But another thing is to think about where situating your project in the world. So with this Apple II example, we have like what you might find in a typical reference manual, where you say, okay, this is how you unpack things, and you have a key card, and you want to know something about hardware, but then you also have like how to program, because people didn't know how to program necessarily, or they had to make their own programs because there were no programs to run. Today in computing, we have a lot of programs. Usually, if you're developing hardware, you just worry about the specs, and people just kind of work on the programming. They have other resources for that. So that's not something you need to include in your documentation. But you may include, say, something like how to or a why. And you wouldn't want to put it into this dense manual. You might want to distribute it into different smaller files that people have access to on the internet. So as technology changes, as times change, as the outside world changes, our documentation needs to change with it. This is an example of more modern documentation. This is the Arch Linux Wiki. So this is actually a very good example of different types of documentation. It includes Arch Linux, of course, is a distribution for operating system, Linux operating system. They have, the information about the distribution, about their community, and other things. So this is all documentation sort of organized in the way that this Apple II example is. But you get these different, documents, they're organized differently, they have different foci. And it allows you to still do, interact with the project at different levels of technical expertise. So some people using this are very technically savvy, and they may need specific pieces of documentation that are highly technical. Other people are just casual users who might join the community, might need to know about the code of conduct, the IRC discussion channels, maybe some international communities, They might not need to have all of the highly detailed documentation, and that's okay. Distributed in that way. So this is another example where you have kind of their introduction, they have some principles that they follow, because this is how does this differ from other Linux distros? So they have a focus on simplicity, modernity, pragmatism. Those are sort of their values. It almost looks like what we went through with the project vision statement. Except that this is kind of stating what we do, why we do things. And it's very different from like highly technical specs. Although it's almost as important because you want people to frame what you're doing in terms of the rest of the world, in terms of that world of Linux distros and why you should pick this. And then, of course, you can go down and, find out more detailed things underneath that. And it serves as all things to all people, basically, but in a different way. So, I talked about README files before. If you're interested in learning more how to do that for your project, there are these resources here. There's the ultimate guide to writing README files. There's this thing called awesome README files, which is just kind of some templates that you can follow in there in Markdown. So, this is I can't remember which article this is. I think it's the first one. This screenshot here. So a well-crafted readme.md file, which is written in Markdown, is essential for any software. It serves as a gateway to your project, providing potential users and collaborators with essential information about your project. So it's not technical specs, it's kind of this information about the project. And that's another thing about like documentation, you want to pick different levels of technical sort of expertise. So you want to write certain documents for certain audiences. If you're writing an introduction, you don't want to be like dive right into some really dense technical jargon. You want to have that. This is our project. This is why it matters. Listen, and like the Arch Linux example. If you dive into a lot of technical jargon, you're going to attract basically your development team. No one else will care. If you have it in a much more accessible, written in a much more accessible manner, and then have highly technical documentation reserved for people really doing the work that require that kind of documentation, then you can attract people from community, from the outside world. So they kind of walk you through how to build an outstanding README file. And they say why a good README matters. There are a couple points there. One is that you want to attract contributors. So if you want to have an open source project and you want to bring people in your community as contributors, having a good README file is a gate. It also helps to set expectations. What are our values? What's our standard process for getting onboarded, getting involved? Provides instructions, so it kind of links to all the things that you need, installation, potential improvements. So there are all sorts of things you can link to in your project boards, governance issues, what kind of versions you offer, maybe things that you want to improve, things that you do well. You can also showcase features, so you can highlight key features and functionality. So if you do something that no one else does, that's a good place to feature and say, this is something we do really well, this is something we're proud of, and showcase it so people can see. And often, a lot of times projects will be differentiated by what they do uniquely or well compared to something else. You don't need to write an advertisement, you just need to highlight what you do. And build trust. We talked about trust in the very first lecture. How do you build trust? There's this social capital aspect. There's this motivational aspect. There's also this just building trust through instilling confidence in the project and its maintainers. Making people think, yeah, they're there, they're serious, and maybe they're, well run as an organization. So that's where, READMEs fit into this documentation milieu. There are all sorts of tools as well where, for example, read the docs. And read the docs allows you to take things that are written in Markdown and render them as these sort of hierarchical documents. So this is an example here where you have this read the docs site, you upload these readmes and then render as this sort of rich text that is hierarchical, so you can nest things. So you can navigate through the documentation in a way that's more like a book, digital book, and then like maybe a README file. They're all based on README files, markdown files, but you basically have this, you're rendering it in a rich text. You're rendering so that you can follow through an outline. You can also use Notion documents. And so Notion is a tool that is it's kind of like, you know, you can use Markdown in Notion, but you can also build things like tables and other types of data structures in a very easy way. So it's kind of like a cross between sort of a conventional documentation file and something like a database. You can store things in Notion. A lot of people use Notion for their documents, for note taking and things like that. And you can save them sort of in a way that's easily searchable. And so this is a graphical user interface oriented database. This is often useful for writing documentation, especially at the level of internal documents, or planning, or sometimes archival features where you want to like build an archive of documents or of notes and then search them later. So there are all sorts of tools that allow you to build, documentation, not just for technical purposes, not just for public consumption, but for internal note taking and internal sort of things that you want to record. And so it's a lot of this institutional memory might end up in the Notion document. That's a good way to organize it. So again, this is a Notion document. And so one of the things that there's another kind of platform called Coda.io. And I'm not going to go through Coda and how to use it, but it's just another way to kind of take notes, kind of like Notion. But the really cool thing that the Coda team has done is they created these sort of visualizations of how people use them. And so, like I said, there are different ways that we can use documentation in communities and projects. One of those, of course, is to click this technical information, make it public facing. Sometimes you want technical information that's inward facing to the team, keeping this, this sort of institutional memory. Sometimes you want to communicate with their community or the outside blogs or something else, and so those kind of documents. But this is where we have documents in a team, and this is like again based on this agile type style of management, where you have these squares, which are the docs, these orange squares, and then the blue circles, which are the users. So basically, what they're trying to figure out is like, how do people use documents? If we can track users and how they interact with documents, we can figure out what kind of how many documents to create. So if they're documents where no one's using them, we can minimize them. And B, how do we arrange them in the organization? So if there are certain documents that everyone uses, we need to put that up front and center. If there are documents that very few people are using, we might think about making that sort of semi-private or not emphasizing it so much. And they're just ways to help you with strategy. So this is a study that's from this blog post, how teams use Coda, a few different patterns. So these are usability patterns for implementation. So the first one is the user nova. And that's characterized by these two big documents here, a bunch of smaller documents. So these might be like, big technical documents. These smaller ones might be, small readmes or something like that. And basically most people are interacting directly with these two big documents. And some people are interacting with these smaller documents, but that's, maybe they're like specialized documents for certain team members, very highly technical. So that's one pattern of interaction is the user nova. The second is the doc explosion. So this is kind of where you have a lot of documents no one's interacting with. Right, one person is interacting with 15 documents, and some people are interacting with maybe one or two. You have a lot of documents everywhere, various sizes, and so you can observe this pattern and say, well, okay, maybe we need to limit the number of documents. Maybe we need to consolidate things, maybe we need to guide people better to those documents using like a guidance tree or something like that. So we can focus people onto, maybe the documents that are most relevant. So you can look at something like this and say, like, our strategy is working or not working, our strategy is maybe can be improved, our strategy might be working very well. It just depends on what, at least you have this tool to evaluate. The third one is the classroom, which is where you have students sitting around the main document and they're learning from that document. There are a couple of documents here that form these sort of clusters of users that don't really interact with the same documents, which is interesting. One person interacts with all three of these big documents, but no one else interacts with all three of them. Which I don't know what that means, but that's something if you have sometimes your community will, or your organization will have a particular social network structure that might explain this. Sometimes you can leverage that social network structure to sort of design documents in. So just as an aside, there are other ways you can like kind of optimize people who are participating in your organization, how people are working effectively together, and the documents here. A tale of two docs, where you only have two big docs, and everyone's kind of reading them. Some people are reading both, some people are reading one. Squad goals, where you have a diversity of docs and you have a diversity of users, and it's basically a free-for-all. And that's very hard to get a read on, but that's what they call that. And then the archipelago, which is where you have these disconnected communities of people or teams of people who are all looking at different docs. And that might be where you have highly specialized teams working on the same, maybe parallel problems, and they're all kind of consulting different things. But that's something you would want to know. So the point here is that there are a lot of different sort of usability strategies for documentation. The way you create the documentation should kind of match how you, the sort of the user, how you're using these things and the social network of your organization, your community, your team. So now, I want to also highlight this tool called ZenHub, but I want to highlight some of the tools that they have brought to project management. So ZenHub is a platform, it's a paid platform. Basically, it's like GitHub Issues we'll talk about for quiz 2, except that it has these two different types of tools, roadmaps, epics. So in the ZenHub world, roadmaps are these things that go from, so basically it's where you can take an issue, take a to-do thing, and you can put it into a timeline. So for this thing here on the left, I have this photo upload feature. So I'm trying to build this sort of multimedia program where I'm processing. And I have a number of to-do issues here. I need to create a photo upload feature. I need a camera user interface. I need to request an API to interact with some other platform. I need to create a video editing feature and so forth. So there are all these different issues or to-dos that I need done. And they all are kind of assigned to time completion. So I start the photo upload feature on March 14th, and I plan then that I'm in. And what I can do is I can have these stand-ups where I have people tell me, whoever is in charge of the photo upload, how much progress have they made? What have they done this week? What will they do next week? And from that, I can estimate the time to completion. So I can actually count. Like I started on March 14th and I go for about a month and we make good progress. We might be halfway done with our feature, and we'll be right on time because we can see that we're about halfway through the estimated projected time. And so if we just stick to this, if we always see this every day and we meet daily and we report on our progress, and maybe we take this issue and break it down into pieces and say, what needs to be completed for this to be completed? Maybe there's 5 issues that need to be completed for this whole thing to be. And we can actually use that to estimate how much time, how much time how much we accomplish and how much do we have yet to accomplish. And so we can keep track of time in terms of what we need to do in our project. We have a specific to do, we can break it down into issues. We can say that issue will take a certain amount of time. Once that's completed, we know we're on track. Now, sometimes there are things that are dependencies. So this camera UI may need to be in place before this photo upload feature can be completed. So we need to focus on the camera UI, but more importantly, we need to focus on getting it done in the right amount of time, or else we risk not only delaying the camera UI, but we also risk delaying the photo upload. So if we delay our camera UI for some reason, if we push this back to May 4th, then the photo upload feature gets pushed back into June. And then maybe deleterious to the project. But what this does is it gives you this way to manage the flow of time in terms of what work is done, what work needs to be done, and the dependencies. So if something needs to be in place for something else to get done, those things have to be worked on in a way, first of all, you can kind of know what needs to be worked on first, what needs to be worked on second. But then you have to be sort of consistent with your work and the amount of time you devote to it. So the camera UI needs to be right away. It's a high priority. And then when that's done, then the photo upload feature is the high priority. And if you have to shift people from one thing to another, then you may do that. But this allows you to track all of that conceptually. So that's roadmaps. And this is actually quite useful for, different managing your workflow, managing your issues and so forth. The other thing are these epics, which are basically, you're going to see later in the class, these are like GitHub issues, where it just kind of talks about how it has details of this issue, this API interface here, wherever this is, probably request API. This is going to be an issue, or better yet, an epic, where you can put tags on it to say what it is, what it's relevant to, and then some of the goals and things that have been accomplished. So these tools together can give you a very good sense of how to manage time in your project, how to manage these things as sort of the smallest unit of activity, and putting those things together and managing your project effectively. And so this alone doesn't really have anything to do with documentation, but it allows you to organize things. So, you're able to organize milestones from a set of GitHub issues. So in a sense, it actually does give you that sort of guidance that documentation would give you. Organizing tasks using a timeline allows us to track milestones, which are essential for complex tasks like public events and other things. So, in terms of milestones, these are specific points on a project timeline. You have these anchors, which are concrete goals, you get an associated date. Your prospective milestones, which are things in the future, can be flexible depending on how much is achieved. This focuses efforts. And when you build your timeline, sometimes when you build a timeline in a project, you're building a timeline for multiple things simultaneously. So one way to sort of attack a project is to have different things going on at the same time. So you parallel issues going on or activities going on at the same time. So if you go back to this timeline, you might have the photo upload feature happening. You might have this video editing feature also happening. And if video editing feature, if you're ahead of schedule on this, you can shift people over to work on this photo upload feature if that's more essential. Or if you get stuck on something, video editing feature, and you need to push the deadline back. All the people working on this have nothing to do. So you might assign them to the photo upload feature, finish that fast. You can move to the project. Basically, you can use time both as sort of a way to manage contingencies, estimate how much time things will take, but also to sort of optimize how people are working on things. And hopefully that helps you achieve your project in a shorter times. So these are epics. This is further reading on this. So this is on milestones and epics, sprints and milestones. So this is all kind of managing this sort of agile/lean type of workflow where you have, different types of project management tools, different milestones, things like that. So another thing you want to do in terms of like managing sort of contributors and helping them into your community. but also having to do with documentation, is that you want to send signals to people who maybe want to contribute, but they maybe are intimidated, they think it's too much work. So what you want to do is you want to be able to help people get on board, not just in terms of like documentation, to tell them where they are, why the project is important, but as a signal to tell them that the barrier to entry is rather, that you don't need to have a huge amount of technical expertise to work on something project. Or to use your project, or better yet, to contribute maybe some code. So one of the ways to do, so there are different tools that we can use that are not really documentation, but they kind of send signals to people in the outside. And so one thing we use are these things called repository. So repository cards are a way to sort of advertise your GitHub repository to say this repository is active. It has 304 stars, and we talked about stars as sort of likes. So people are interested in it. There are 6 forks, so people are forking this. It's written in a language that maybe you know. So these repository cards come as a package. They have all this information on it that serve as as an advertisement of your project repository to the outside world. You can put these repository cards in different places and marketing materials and emails. And it's just a good way to characterize what's going on, to make people think that it's active and it's accessible. You have badges as a service, so this is shields.io. Another way to do this, you could actually advertise these pieces of information in your repository. This isn't in the documentation. This is a README file where there's technical detail in this README, but up here we have these badges that say a couple of things. One is that there's archived data or archived code at this address. So you can link through and find the archives. There are other types of things like stars and forks, and you have that information here. You have the license information, so you can click on this and go right to the license. You have 5 open issues, so you click on that and go to these open issues. So it's saying that there's something to work on. We're well liked, we're well regarded. We have a license that you know what it is right up front. You have this open source badge, which means yes, it is open source. You have this thing that says maintained, yes. Yes, it's maintained. Pull requests are welcome. And we're on this PyP site, which is like another repository distributed software. So there are all these like pieces of information in the README that are very quick to access and send a good message about your project to a community or to a potential contributor. This is the code for making these badges. And we have GitHub, different types of GitHub badges. And then, we think about the different levels of contribution. So in a project, oftentimes we really kind of think about this kind of expertise. So in like a software engineering project, some sort of computing project, we think about these people as sort of the core of the community or the core development team. People who are experts or have high expertise, high level of expertise. We might think of our community members as having a low level of expertise, but still know how to do things like bug reports. And then if they don't know anything about computer code, they might be considered to have no expertise. And those might be people who we might not reach out to, or we might say they're kind of minor members of the community. These people might not be interested in our project. But in fact, that's not really true. We have people who are always interested in projects, but they might not have the level, the technical level of expertise to make a contribution or to be involved in the development. And that's a shame, because that's a lot of wasted skill. There are a lot of people with perfectly good skill, perfectly good perspectives on these problems who don't necessarily know the code, who don't have the expertise in doing the things you're doing. So what you want to do is bring those people in. You want to be inclusive. And so these are just kind of different levels of contribution. But one of the things we can do to be inclusive is to provide these people with no expertise or no code experience tools to help them build something, to help them contribute to the community, to help them contribute to the project. And in fact, those tools exist. They're called no-code tools. And so this is an example of no-code development. Couple of examples. This is the OpenAI Codex. So this is a no-code tool that you can use to work with OpenAI and so you can build AI models. You can work through an API, and it's like a way that you can basically interact without knowing a lot of specialized code. You can build a model, and you don't have to have a lot of technical expertise. This is important because even people who know how to program might not know how to build an AI model. So you have this no-code tool, and you allow people, you give people greater access to the underlying code. You give people greater access to the technology. You also have these Betty blocks. This is another type of no-code tool. It's basically building these block diagrams, which are pretty intuitive. You use blocks to build some process from start to finish, and that process then maps to some code. And so it allows people to build something, they understand the logic of it, they understand the steps involved, but they don't know the syntax. And so it eliminates that barrier to entry. And it gives people who have a good idea, but very little expertise in some technical aspect of coding to see through some of these contributions. And then there's something called Glide, which is a no-code tool, which you click on, you start like this little mini app, and you add pieces together, and you can get these programs written. The program, basically you have these block diagrams or these little icons that you put in place, and the code is written under the hood. But what the contributor sees is the sort of no-code model where they're just putting together, different things that they want to have in their program. And then they can build code. And sometimes organizations will accept that code as is, or they'll have someone who can work through it a little bit to make it acceptable to their organization. But the point here is you can use these kind of tools to bring people in with good ideas, but not the requisite technological expertise, and improve kind of what you're doing as a result. So, you can do this in a number of ways. You can have, there are a lot of distinctions between this no-code set of tools and low-code types of programming languages such as Python. Python is a high-level programming language, so it's not considered to be highly technical. There's some programming languages like assembly that are highly technical. It's a really high barrier to entry. Not a lot of people know assembly relative to Python, but no-code offers you another layer where you can expand. You can lower the barrier to entry even more and expand your pool of potential people who can contribute something to your project in terms of program. So there are different ways you can do this. One way is this rapid application development, which is this topic that stands as a response to waterfall project management. So I talked about Agile earlier, and how the Agile project management philosophy sort of grew out of dissatisfaction with waterfall, but it also, dissatisfaction with waterfall spanned these other types of more focused types of approaches to building programs. So rapid application development is basically using this kind of low code or no code approach to doing iterative design, like we do in Agile, and working through. So you can build something not only with a very low level of technological expertise, but you can work through something very quickly with almost no documentation involved, and you can build something that works. All these different sort of no-code solutions place the knowledge base of programming languages under the hood. So it's handled by a program, it's handled by automation. You can make changes to specifications quickly and cheaply. So this stands in contrast to waterfall, where you have to spend a lot of time changing your specifications. And then no code automates the program so that changes are easily made through this graphical user interface, and the behavioral outputs of the program are easily observed. So you play with some blocks, you see the behavioral change in the program, and you know it works. And then you can just publish it, and you have very low barrier to entry, and you have a very functional system of contribution. And that really stands in contrast to a lot of the things in waterfall project management, where you need to have these very detailed specs. And so, you have this, a couple of questions for no code development. You might say, what can the program do? How does it behave? And how easy is it to use? So in all those cases, what we're doing in no code is we're automating those capabilities, automating the logic, automating the interface, and bringing things closer to sort of people who want to be involved in the project, but often are stymied through these technical barriers. It also helps teams to mock things up more quickly and to be more effective in the time that they're spending developing things. Okay, so that is all for today. Remember to turn in your assignments by the end of the day if you can. And have a good weekend.